Hello, Ramsey. I'm Beverly Wright.
Hey, how are you?
Good. We can see we can see your face and we can hear your voice really well. So thank you for joining us and thank you for being here to talk to us about non-English search as a machine learning problem. I'm really intrigued by this as we move into a more
Yeah,
and marketplace. So we will let you take it away, sir, and I'll come back when it's about 2 minutes until to let you know that we're close on time, and I'm also going to monitor the discussions. And if we have Q&A time, if you happen to be able to give us a few minutes for Q&A, I'll help deliver those to you. Okay?
perfect. So, shall I
Yep,
start?
you shall. Thank you.
Yeah. So, guys, hello everybody and welcome. Thank you for taking the time to attend this session. I feel very humble and honored to be here today to talk about non-English search as a machine learning. Guys, before I start, let me introduce myself. My name is Ramzi Alqrainy. I'm a Chief Technology Officer at OpenSoup. I have a Master in Information Retrieval and Artificial Intelligence, focusing on dealing with Arabic content, contributor in Apache Solar, and contributor in Slack. I'm a technical reviewer for a few books related to the big data, Hadoop, Spark, Solar, and Lucene. So I would love to start this presentation with some introduction about my company, which is OpenSoup. So OpenSoup is the biggest classified in the Middle East and North Africa. We are running across 19 countries. Each country has its own characteristics. So we are focusing on building the localization. We are serving many verticals from merchandise, automotive, real estate, services, and jobs. So at the end of the day, we are providing our users, buyers and sellers, a platform to connect them together. We are number one and focusing hard to be to go globally soon. I will start this session with this question. We are running in Iraq, and imagine, guys, if you search for Obama in Iraq, imagine what do you get? If you think about it, you will not get it. That's right. Chrysler 300C in Iraq. This is Obama in Iraq. So this is one of the challenges that we are facing in Iraq, and we need to solve it. And this is one of the things that we will talk about it. But before we talk about solving all these challenges, we need to talk about the importance of Arabic language, why the Arabic language is important, and why it's complex also before we start. So guys, Arabic language is the fourth spoken language globally. The internet users in Arabic region in the Middle East and North Africa grew up from 135 in 2017 to 225 million users in 2019. This rapid, this exponentially growth within 2 years uh, will leads that Arabic language is the fastest growing language in the world. But the challenging here that the content of the Arabic is not huge like English or maybe French, and this will add more challenges and headache on us to build like smart search engines to understand all these content. So guys, Arabic language poses many challenges for retrieval when dealing with the social media, such as microblogs and the informal web content, such as a discussion and forums, and reduce further complications. These complications relate to the use of text decoration, abbreviation, and other challenges. So I can group all these challenges of when we deal with the Arabic content with five core challenges. I will start with orthography, diacritics, morphology, dialects, and Arabic. Yes, guys. I will give you some insight about each point for them. I will start with Arabic orthography and print. Imagine, guys, that Arabic has right to left connected script that uses 28 basic letters. The same letter in Arabic has multiple position change shapes, and these shapes, it depends on the position of the word. So one of the example in the Arabic, the letter of Ain, the shape of Ain varies between multiple shapes, depends on the position of the word. So you will see it in the end. It's different than middle. It's different than start and isolated. The second challenge, which is Arabic diacritics. So before I start with Arabic diacritics, these challenges have, of course, trade-off will make the ambiguity of search engines, of building search engines, and the complexity of handling Arabic language comes from the variations of all these challenges. So imagine, guys, the same word with different diacritics will give you different meanings. One of the cases, which is the word of alam. Alam means in English knowledge, sorry, flag. And ilm, the same word, but with different diacritics, means knowledge. So the same word will give you different meanings and search engine. Here we have like actually the common solutions we are doing, which is removing the diacritics and try to understand from semantic or based on the sentence, or maybe you will take the risk or building the natural language processing to understand that position and understand the diacritics, because some diacritics will give you some insight that this is noun or this is verb, and based on these variations you will understand the meaning of that word. Number three, Arabic morphology. So yes, guys, this will add more complexity of handling Arabic language, because the variation from morphological, this will generate several words from the common root. One of the examples, kataba, which is write. I can generate from kataba, katib, which is writer, kitab, which is book, maktub, written, and kutayib, small book. So I can generate multiple words from the common root, and this will give you more challenges and will lead that the Arabic words are divided into three main types, which is noun, verbs, and practice. Like proposition, and this proposition actually in the search engine you will add it on the stop words. Arabic diacritics, Arabic dialects. So in the Middle East and North Africa, there are 6 dominant dialects. The same word, sometimes it's allowed in Jordan, for example, it's a bad word in Egypt, and this will add a headache for building the intelligent search engine and will push you to focus on the localization in the Middle East. And you can split the Middle East and North Africa to 6 regions: the Gulf, which is the GCC, Egypt, Levantine, which is Lebanon, Syria, Jordan, Palestine, and Iraq. Because the same word, you can spell it or pronounce it the same across all regions. For example, I want in Egypt called Awiz, in Gulf Abra, in Iraq Abi, in Levantine Biddi. Imagine, guys, it's like totally different countries, different dominant, and sometimes the same word you cannot spell it in another region, on another country. And lastly, Arabizi, which is this is common challenges coming from the generation Z, which is Arabizi, which you can write Arabic with English letter with numbers. So imagine if you want to write, for example, Ahmed, you write A7MAD. This challenge will we need to focus on it and build like a system, and we can use for example one of the system Yamli to transliterate this word to Arabic to start doing the search, because when you have the content, the people, they are not writing in typical way. They are doing some mistakes. They are not writing with the acrobatics or the same dialect sometimes. Of course, all these challenges will add more challenges when we deal with the stemming. So the stemming algorithm, this is one of the challenges that you will deal with Arabic language, because it's hard to go back to the root of the word. One of the common algorithm, which is something easy, but it's not like a big accuracy, which is the light 10 stemming. And this is what we start building on top of it, and it's outperformed the other approaches, and it's becoming widely used in Arabic information retrieval. Uh, this light 10 stemming, they are focusing on rule-based prefixes or suffixes or affixes to try to remove them. Changes that we did, for example, when you take the Arabic word and convert it to the English and start dealing with it with the English stemming sometimes. In English, it's easy if you deal with the plural, for example, like S or IS, but in Arabic, you will face a lot of challenges because sometimes the same word will be changed completely if you convert it to the root. This is some insight and group by about the English, about learning English, or especially the Arabic challenges that we facing in the Middle East and North Africa. And now I need to talk about the classic similarity. So let's think about the problem with classic models of relevance. The core algorithm of search is called TF-IDF. And for example, Solo, because we are using it, Solar uses an algorithm called BM25 that improves upon TF-IDF. But the basic ideas is the same if a distinctive term appears more frequently in a document, and that document is more relevant for that term. This is good enough for most searches of most document collections. However, there are times when just looking at keywords are not enough to accurately capture user intent. BM25 BM25 is good general purpose scoring model that proofing of it is somewhat difficult, especially in a global systematic fashion and not an ad hoc case by case whack-a-mole basis, but perhaps for your enterprise, there are many valuable business specific non-keyword based relevant factors you want to leverage. In these cases, keyword search just is not enough. So the solution, learning to rank. This is one of the solutions that help us to solve a lot of our challenges. So one of the ways with Solar to address this problem of relevance is through an algorithm called learning to rank. Yeah, learning to rank is a machine learning technique where we teach the computer how to rank items. We do this by choosing features which you can think of as a relevancy factor that we think the algorithm should weight in it. We also need a source of ground truth or order one source of this is user behavior. Luckily, that Solar help us on that and provide some nice builds, basic building blocks for implementing learning to rank. And we need to capture user behavior as well as pipelines for applying these techniques in order to understand learning to rank. We use machine learning to predict whether or not a query like iPad is relevant to a document. The feature is used to feed the model are similar kinds of relevance factors that you would use to feed solo ranking function. Things like the score of title matches or the score of body matches or perhaps the number of views the document has, similar to how spam classifier learns from training data in the form of emails learned to rank models are trained in the same way or with the ground truth relevance label. So if we need to focus on the solution and see how we can put steps to focus on or working on it also, we will start with, firstly, we need to decide on which feature to feed the model. You could think of features as a relevancy factor, like title match score, body match score, or maybe signal-based feature. So next, we use one of the system or figure out a solution to create ground truth from clickstream data. What we can use, maybe one of the common solutions in the Lucid Work Fusion, for example, that can help you to create a ground truth from clickstream. So ground truth is simply a large list of queries and the most relevant document for each query. Lastly, we use Solar Learning to Rank implementation to help us train a learning to rank model. Here, guys, we'll talk about the stack. So the traditional search stack is based on a little bit on information retrieval where you have two main processing stages. You have the offline part and the online part. So offline, you can say acquire a set of documents, some sort documents you either web crawler or you kind of get them from user and whatever, depending on your application. And there is a lot of kind fuzzy putting metadata engineering sometimes that's very hacky, where you do just a script to clean up your data and kind of put it into your index. And a lot of Lucene and Solar already does the representation function and how you present each of fields in your document separate column. Then you create an index with inverted 10 frequency. So in that case, you could quickly retrieve the different document. Then that all happens offline. All these cases will happen offline. Now, online, when you get a query, you do like under the hood of you use, for example, represent the function as a function, then gets passed on as a query. Then there is some sort of similarity, typically TF-IDF, for example. They retrieve the relevant document, and the part in purple, guys, in purple, is where more and more of a state of art is moving. We're going to not just having a state stagnant similarity calculation, but we need to have the relevance feedback based on the history of what user clicked. So, for example, I'm saying I'm searching for shoes, and I really like certain type of shoes. Then just to my taste will tune the relevance to me, and let's say shoes for someone else, they are gonna look for compact shoes, for example. I don't know. So the part is now a lot of it's moving, and where the power of having Lucene open source and Solar, we can start taking advantage of that. Combined together, we have this utilized model that we trained earlier, and then we can put it in this plugin. So then effectively in search, and then we're gonna do the phase 2 of ranking together in it. So what this means is that you are effectively doing the evaluation of the model of the ranking inside search. And you can do that because Lucene, you can plug in this engine. So what we have here is how this ML scoring architecture work, which the phases of filtering and ranking would all happen in one step. Here, Lucene, sorry, here's the big workflow of here is the big of your workflow for how to implement learning to rank in this diagram, guys. It's going to start with the step number one in the lower left and follow where the arrows point. So number one, we upload a set of features to be Solar JSON REST API. Next, using any solution for ground truth, like maybe fusion signals or any solutions, we produce a ground truth ordering for our results. And once we have that, we can use a Spark job to extract features, your vector for each query number for features vector, and then use to serve the feature vector service input to our model trainer. Number five, once the model is trained, we upload it to Solar. And lastly, user will see the result in the order of provided by our learning to rank model. Here, guys, the question is, but is it better? Yeah. Here, training a few different models, namely straight out of the box Solar and textual features only. The logistic regression model using all features except signal features, and a logistic regression model using all features included signal features. The performance metric we use in this graph is recall at 5, which is simply for giving query our percentage of relevant document appear in the first 5 results average for over all queries in the held out test ground truth set. The signal feature use applies a query aware of boost to documents that are more frequently clicked or purchased. The learning to rank model will automatically weigh this feature along with all other textual features in order to maximize relevance according to our metric. As you can see from the graph, there are significant relevant improvements observed over out of the box Solar BM25 ranking and even over the logistic regression train model when using signal features. So the goal of this to demonstrate how to implement learning to rank, and this, if we add the stemming, Arabic stemming, normalization, try to remove the diacritics and building some NLP that we did, this will help you to add more accuracy for the relevancy of the user. Here, guys, we thought it was limited to Obama, but actually, imagining in Kuwait, Ghost is a Mercedes as a class, 140. In Kuwait, Whale, it's a Mercedes as a class, W220. And in Jordan, Submarine, also it's a Mercedes as a class. You see, the same word in each country has its own localization, so we need to focus on this localization. Building learning to rank help us to boost all these data and give it more accurate data for the users. But of course, we have a problem with it, which is the cold start problem for the first. So we are logging more data for the user and try to train a model based on the clicks of the user. And thank you, guys. Thank you, guys, for your listening, and I'm happy to hear any question if you have.
Could you go back to slide 23? Thank you so much for this. I don't think I realized how behind we were in other languages. Can you go back to slide 23 just for a second?
The
yes,
slide
sir.
number? What was the number, sorry?
It's about 7. I think that's 16, if I can tell, if I can see it right. Yeah, go one
16?
more. Oh, okay. These look like they have numbers on the bottom right. It was the one that had the chart, and it was slide number 23. Yeah.
23, yeah. Yeah.
So can you go to 23? It's about one more slide, I think. There we go.
Here.
Yes. Can you walk us through that chart on the top right, please? Tell us what those numbers mean, if you don't mind.
Yeah, of course. Here, one second.
Just
Well,
maybe the green bar. I couldn't tell if it was a difference between models or if it's
yeah, here the training,
awesome. Okay, yeah.
yeah, here training few different models, which is straight out of the box solar on textual features only, logistic regression model using all features except signal features, and logistic regression model using all features, including signal features. So the performance metric we use in this graph, we install some script from Kaggle, and we use in this graph is recall at 5, which is simply for given a query, our percentage of relevant documents appear in the first 5 results. Average of over all queries in the health or out test run truth set. So the signal feature use applies a query aware of boost to document that are more frequently clicked or purchased. The learning to rank model will automatically with this feature along with all other textual features in order to meet the maximize the relevance according to our metric. So in this graph, you will see the significant relevant improvements observed over out-of-the-box Solar BM25 ranking, and even model when using signal features.
Okay. Is there a minimum we talk about like is it better? Is there a minimum gap? Like it's more work. So what would you consider to be like, oh well, this is going to be this much more difficult, therefore it's worth it? Like what makes it worth it, in your opinion?
Multiple things. The first thing, understanding the Arabic content, the challenges, and trying to build like multiple things with the learning to rank. This will help us to increase the accuracy. For example, when you deal with the Arabici and try to convert it to English, and then from English you can translate it to Arabic, this will help us to understand what the user is
Gotcha.
trying. Doing the evaluation of your search engine, like calculating the precisions, getting more recalls, and trying to understand what is the problem with your queries and building the personalization. This helped us also to push more about the relevance, because open source as any classified like maybe the Craigslist, we have a lot of many of verticals, so we need to personalize the search based on the verticals. When you go to the autos, we should give you more user experience about the
Yep.
cars. It's totally different than real estate. If you are looking up for apartment.
Okay. We have a few questions and we only have 1 minute. So I will choose this one, and then the other ones hopefully you can answer on the Q&A if you can hang out for a minute. Is this LTR a real-time model or is it batch model?
Actually, we can build it as a real time. I can't say real time. I can say a near real
Ah,
time.
okay.
But yeah, but as a start, we start as a batch model. Why? Because I need to control all the steps and to evaluate each steps alone and try to understand what's happening. We and After that, when you make sure that all the blocks are working fine, you can go to the real time model. But yes, you can do it real time if you use like for example Spark jobs and building the pipeline.
Gotcha. Never easy to do though. Okay, great. Thank you
Yeah,
so much, Ramzi. Really enjoyed your presentation. Just the awareness alone,
thank you.
totally worth it. So really appreciate it. Thank you. And feel free to stay on the Q&A. And I'll see the rest of y'all
Yep,
over in the session with Renata about how to launch your data career. Thanks, guys.
yep. Thank you. Bye bye. So one of the guys asking about, are you using a universal sentence encoder, multilingual to understand the query along with the language before calling an LTR? The answer is we are using similar to universal sentence, but yes, we are using semantic. We are building the NLP, the natural language processing, on our context. So what we are doing, we are building tokenization, normalization for Arabic, stemming, and other search flow to understand the behavior of what we have. And the learning to rank is the last thing we applied. Can PERT-like embedding models be directly applied to Arabic script? I'm sorry if you can tell me what do you mean PERT? I got all. Then just saw these were invisible second ago.